Welcome to Stage 2 Chemistry, and today we will be working with assigning oxidation numbers. Now, so this is one of the techniques that we use in chemistry, and basically this just determines what charge certain atoms have within a molecule. And in this way, yes, I did do an assigning oxidation numbers video where I actually wrote it out myself. However, due to being left-handed, this becomes sort of a problem, let's say, due to the fact that my hand actually covers. So therefore, to, let's say, fix this problem, we're going to start using PowerPoint presentations. So, if you have not watched the other video, I'll probably be taking it down sometime soon anyway. So in assigning oxidation numbers, we have certain rules. There are three main rules in which I have listed. Step number 1. Oxygen always has a -2 charge. Okay? Hydrogen always has a +1 charge. All elements are 0, assuming that they are not given a charge, positive or negative. This will be explained later, however. And 4. Fill in the rest. In this video, I will not be discussing about oxygen in terms of when it is found in chemicals such as hydrogen peroxide, as oxygen then becomes to a -1 charge, I believe. This video is just to convey a general concept of oxidation numbers. Moving on. So the first example I would like to use is iron oxide. Iron oxide is Fe2O3. First, we must identify what atoms are within this molecule. Hence, within iron oxide, there are 2 iron atoms and 3 oxygen atoms. Hence, in the following rules, we know that the total sum of the charges must add up to 0. This is very important, okay? Continuing this example, oxygen contributes to a total of -6 charge, and iron is unknown. Remember, oxygen always carries a -2 charge. Hence, 3 times -2 will equal -6. Therefore, in solving this problem, we can use simple algebra to solve for what charge is actually being provided from an iron atom. Therefore, we can assign Fe2 as 2x, as there are 2 iron atoms. Using simple algebra, we can then solve as to what charge iron provides, as I have stated in this PowerPoint. Hence, 2x plus 3 times -2 equals 0. 2x equals 2x takes 6 equals 0. 2x equals 6. X equals 6 divided by 2, which therefore x equals 3. Therefore, for each iron atom, it contributes to a total of a +3 charge. We're going to move on to another example now, monosodium phosphate, and its chemical structure is NaH2PO4. Once again, we identify what atoms are present within this molecule. We know that the total sum must add up to 0 in this scenario, as I have not given it as a positive or negative charge. Therefore, there is 1 sodium atom, 2 hydrogen atoms, 1 phosphorus atom, and 4 oxygen atoms. Therefore, in using the rules once again, hydrogen always carrying a +1 charge, as there are 2, therefore it's providing a +2 charge. And oxygen always carrying -2 charge, 4 times -2 is -8. So, however, we have a problem. We have one sodium atom and 1 phosphorus atom. This becomes problematic as there are 2 unknowns, let's say x and y, but you can't really, do much with that. However, we can actually solve to what charge the sodium atom is actually providing in using a periodic table. Now, we can observe that sodium, being Na, is in the first column of the periodic table. In using the periodic table and this first column, this suggests that sodium is providing a +1 charge, like hydrogen, found here. So continuing this example of sodium, yes, I'm going to forget the chemical. Therefore, sodium is assigned a charge of +1 as it is found in the first column of the periodic table. Hence, to summarize this, the total sum must add up to 0. Now, we only have one unknown. This one unknown is the phosphorus atom. Remember, it must add up to a total of 0. Therefore, we can assign the phosphorus atom as X, as there is only one phosphorus atom. Hence, 1 plus 2 plus X take 8 equals 0. X take 5 equals 0. X equals 5. Therefore, the phosphorus atom provides a total charge of +5. Thanks for watching, and if you want to request a specific videos, I will be taking, I guess, requests for stage 1 chemistry and I guess stage 2. However, in using this information, I am still currently a Year 12 student. Therefore, I recommend that you continue researching into what you are learning, such as oxidation numbers, as my information might not be, let's just say, totally correct. It's just that it somehow works that way, or either it's just simpler for me to understand. Please leave your comments down below. If I have made an error anywhere, please point it out. This allows me to improve myself, as this allows me to review some basic chemical concepts in any case. So I'll see you guys in the next video.